even talk about indexing, let me drive you back to your elementary mathematics. How many of you remember number line in mathematics, where you have put your positive and your negative numbers? So at the middle here, you have your 0. You have, so as you move to your right, you have 1, we have 6 to infinity. And this on the other side, we have -1, we have -2, -4, same like that to infinity. So with Python also works with indexing, right? So from the first item in each of your variable has an index of 0. So for example, and you want to call on your index, you use the square brackets. So for example, I have my name. My name is Promise, right? Yeah. If I say name, use the square bracket and call 0, it will be return P, because Promise P is 0 index. So after P, the next item would be 1, and just continues like that, depends on the length. Since I have a length of 6, the last thing I can call here would be 6, because remember we're starting with 0. So E, if I call on, let's say 7, it will return like this is out of range, because index, I don't have up to 7 items in my list. Yeah, so we have it as 0 to, we call 0 or 1, let's call 2. 2 will call on the third item on the list, and the third item would be O. By the time I call O, yeah. We could also do negative indexing. With negative indexing, you start from, so if you start from -1, -1 will call out the last item in that variable. So if I do name square bracket -1, it returns the last item in that is E. So I could do up to -2, -2 will return S, and I could do -7, because I have 7 items, returns P. So -7 and 0 would be the same thing, because okay, you're reading from back to, it's like reading from front to back, back to front. If you're reading from the back, it's negative indexing. Yeah, so you start from -1. I hope that's clear. Hope we're following. Can I move forward now? Am I free to move forward? Okay, thank you. Okay, the next thing we'll talk about is slicing. So I talked about indexing. So slicing is like slicing, like what the name implies, slicing, taking a portion of what I have. So my name is Promise, right? So I say name. So I want to slice. So if I want to slice, I put my start value. I'll use a column and put the end value. So I could say, let me start from 1. Let me start from 2. What's 2 on my list? 2 is O. And say use the column. Give me from 2 to 6. What do you think this will return? What do you think this will return?
It will give you the values from 2 till 5. I think it will exclude the value of 6.
Okay, I take it that you have a prior knowledge of Python, yeah? So this is 0, right? This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So if I call 2 to 6, I will expect to get from here to this, right? So OMISE. But with Python, the last thing you call won't be included. It will just end it in the 5. So if I'm calling 6, I know that, okay, 6 will not be returned. It's only from 2 to 5. Okay, so get that clear. So that's slicing for you. So if by the time I run this, it returns it from OMIS, excludes the last name. Yeah. So if I want to call maybe from the first one, so if I want to start with P, for example, I can do 0 to, let's say 0 to 6, same 6, right? It returns from P to 6. But rather than including it, if I want to pick the first thing, rather than including 0, I just do name, put this, do this, and do this. So when you're starting with this column, it shows you that you're picking from the first thing, so you don't need to include the first thing. So it's this saying, give me everything to the 6th one. Yeah, same thing if you want to do to the end. For example, I want to call from name to, let's say from 2 to the last thing. I'll just put the hyphen. There's no hyphen or column. It tells me, give me everything to the end. Yeah. So you could also do this thing with this same thing with slicing, with negative indexing. You could say name, put my hyphen, say, give me from -5. What's -5 now? This will be 1, 2, 3, 4, 5. -5 is from 0. You say from -5 to the end. It gives me everything to the end. I hope that makes sense. So the next item we'll be covering will be data structures. So for data structures, they are used to store collection of data. So from everything we've been talking about before now, it's just like storing a particular one thing inside a variable. But now I want to group different things inside a variable. We call them data structures. And there are different data structures you could have. So there are 4 of them. So we call them lists. There is a list, there is the tuple, there is the sets, and there is dictionary. Yeah, so these are different data structure. You use it to store collection of data rather than just storing one thing inside one thing, right? So the first one would be lists. So let's talk about lists. What are lists? So lists are used to store multiple items inside one variable. You can create a list using the square brackets. For example, I want to say my list. If I want to specify that this is a list, I'll put in a square bracket, right? And I remember I mentioned that it can be used to store collection of data. So each item inside the list will be separated by a comma. So I can say my first item, let's say my numbers will be 1, 2, 3, 4, 5, 6, 7. So I say print type my list. It shows that it's a list because you specifying this square bracket, the computer is already saying that this, what you are specifying, is a list. So specify that this is a list. So a list can contain multiple data types in it. No, we talked about different types. It's float. So let's specify my list again. My list equals to still my square bracket. I could say I have 1. A list can contain different data types. I could say list, my list is 1. I could now put it 2.4. 2.4. I could put dog, call it dog inside. I could, what other data types have we talked about? I could put true inside the list. I could put, what else can I put? I could say, okay, let me say pen inside. So a list can contain different data types. You don't have to have, it's not like putting everything inside one container. So by the time I print type, it's still my list. By the time I print, it's still a list. You specifying this square bracket at the end shows that everything will, by the time me putting that container, it's telling my computer, I want to put plenty things inside a variable. So it's rather than having, before we have, let's say x equals to 1. But now I want that list to contain multiple things inside the variable, inside that list. Okay, we also look at what can we do with a list? What are the things? Yeah, so within a list, you could even have other lists within a list. So let's try it again. My extend, it's also a list. You have to, okay, just do this. I could say 1, 2, 2.3, so the same thing. Let's say name, call something else, X. So let's even do something. Let's even call, so we have a variable called name, right? Called name. We have what we call, my list is a list. I could just put my list. And let's specify something. So for you to specify a different list within that list, you have to do something like this here. I could not say 4, 5, 7. So, but now this list will be items. So if I'm looking at indexing, so let's run this first. So if I say, let me print out my extent. If I say, let me print out my extent. So if I print out my extent, you see that you have this 1, 2, 3. This is an item. This other one is an item, is a list, and this is another item. So for example, now let's even print out the different method. If I want to think, okay, let me print out the length. What's the length of this, my extent? What length would this return? If you know, just type it in the comment section, or just unmute yourself. What would be the length of this list?
It will be 4.
So somebody, Esther is saying, I can see that you
Five.
have.
It will be 5.
5.
Okay.
It should be 11.
Okay, I understand why you say it should be 11. So by the time I print out length, my list, it turns 5 because it sees this item as 1. So when I print it, it sees this one as the first one. This is the second one. My name, the third. My list, even if it's a list, it sees the whole list as an one item inside the list. Do you understand? So even if I have a list, even this last list I have, I use a square bracket to specify that this is a list, right? So it's calling it, everything inside here is 1, even if you have 1,000 things. So because the item, the main thing is seeing it as one individual element. You get, so for example, let's now use the indexing, for example. to cut that out. So remember indexing. Indexing can also work with lists. When I say my X, then I do, let's try 3. What will return as 3? It returns everything because everything is this list, my extent is seeing everything as 1. If I still call on 4, for example, it's seeing everything as 1. So, but if you want to, there's another thing you can add 2 lists. For example, now let me create a new list. New list is equals to, let me see, B, but let me take out my list, these 2 things that are list control X, yeah? So I want to take them out, but if I want them to be their individual, so rather than having them as list inside the list, I want to have them, so just extend the list. I could just do plus this. So by the time I print, if I print out, let's say, what will be the length of new list?
It should be 5.
Why is it 5?
3.
Okay, so
3.
I think we need to do
It should be 3.
we need to vote.
3.
Okay, if you are for 3,
It
raise
should
up
be
your
3.
hand.
Yeah, it should be 3.
How would I be going to raise the one?
There's a raise up hand function with Zoom, yeah. So let me shock everybody. Say 5, right? Okay. How many of you are surprised?
How? I'm surprised.
Oh, I'm surprised.
I've done the jury right. So first, before we even do that, let me print what's my list. Let's see it. So because I'm doing plus, so it's taking everything as different items. It's not putting that list inside the list now. It's now spelling everything out as so each item is 1 item in each everything. So now rather than having this where you have 2 things like the list containing a list, this list is not containing any list inside. It's just containing its own item inside the list.
More like combining everything.
Yes, like I can combine other than having. So when you just specify this inside, just if you do it something like this, where it's when they specify that extent here. So I'm calling it inside, showing that this item is a list. Let me have a list inside the list. But when I'm adding it, I'm not having a list inside the list. Like I'm joining, I'm merging them together. So like I have a bag full of fruits. Maybe I have a sack of fruits. And inside that fruit, I could say, okay, inside that bag, I could say, let me have different bowls of fruits inside that fruit, inside the bag. So I have this big bag of maybe oranges. But inside that big bag, I want to put different little containers of orange inside the orange. So it's me having like a list inside a list. But if I have this orange, I say, okay, this orange, add this orange to it with the full bag. So it kind of empties everything and pours everything together. So you're asking what my list was before. My list was a list. So this was my list, was a list in its own. So you should understand the difference. So when I was creating this extent, I called this, I didn't use the add function, just to specify it as an element inside the list. But with this add function, I'm adding multiple lists together to become like, yeah, it's more like expanding. So I hope that doesn't confuse anybody. Yeah. So what else can I, so another thing another way to extend the list also, so we're already talking about extending, like adding things to a list. So I could use the plus sign. I could say my list. So if I print out my list, for example, this is my list, yeah? So I want to add some things to that list. Let me see, new list too. Let's say new list, okay? So if I want to add an item, so I have my new list as this, right? So for example, I want to add a new item to this list with new list. And I'll do dot extend. New list dot extend is more like adding items from another list to that list, right? So by the time I do new list dot extend, so I have to call my list, my list. By the time I do this, if I'm printing my list again, the new list I've created, the new items would have been added. New list. So if you see that before, my new list was 4. By the time I extend this, so I'm adding what was in my list. So it's adding these extra items in it. Yeah, so you could, the way to add 2 lists together, you could either use the plus function, you could use extend function dot extend, or you could do just something called append. So for example, I have, let me create a new list. Let me create an empty list. So let's say my list now. So let me just delete this. So we have, let me just take this up now. So we have a new list. Let me say my new list is empty. By the time I print out new lists, my list is empty. So if I say, okay, new list dot append. By the time I put append and I put, let's say, cats, for example, it's adding the cats to the list I have. So by the time I run this, append, sorry, it's double P. Yeah. I could say, okay, my list dot append cats. I could do maybe my list dot append goats inside my list. Yeah. By the time I run it, by the time I print, so it's overwriting whatever I have before. So I have cat, dog. So to remove list, so we'll talk about how to add items to list. So to remove something, I could just say my list dots. So with pop, you'll be including the index. So before we even use pop, let's use remove first. Remove. If I use remove, so if I want to remove something from the list, I will have to call what do you want to remove. So if I do this and put this V, okay. So if let me print new list, C, V. So if I use my list dot remove, if I print out my list again, it has removed cats from it. So now I'm teaching you how to add things to a list and how to remove things from a list. So remember, indexing also works for this. If I do index, let's do my list. My list, this 0, what returns? It returns it as 1 because 1 is the first item. If I do new list, let's do 2, returns it as dog, right? So since we know that dog is the second item, if I want to say, okay, I want to remove dog from my list, I could either use my list dot remove, but this time I want to use pop. But with pop, rather than calling the item itself, you'll be calling the index. So if I say my list dot remove 2, dot pop 2, sorry, if this runs, it's removing dog from the list. So by the time I print my list, so does that go out? So dog has been removed from the list. Do you understand? So those are ways to do list. So if you want to add list, for example, we want to use this plus two, it has to be a list. I can't add, for example, I want to add something here. If I want to add, like, for example, just a word. And if I do this, let's say promise, it will return an error because you can't add a list to a string. Yeah, so by the time I do this error, you can't only concatenate, not a string, you can only concatenate a list with a list. So if I want to do this, so for this to add very well, just use your square brackets, just specify that this, you are converting it to a list. So if I run this now, this would work. So just thought to clear that out. So the next thing, so there are other things you could do with a list. So those are your assignments you need to look at. So there is the sort list. So you could let's talk about sorting of lists. I think this is important to talk about. So if we have cats, we have dog, you have bats. This is I'm creating I'm assigning a new list to so this is my list, right? So by the time I do this, my lists, yeah, by the time I print this, so I want to sort this list in alphabetical order, just do my list dot sort. So what would this do? So if I print out my list now, just print out my list, it has sorted it alphabetically, right? So you could also do it in reverse order. So you could sort using the last letter in your list. So rather than using the first letter, you could sort using the last letter in the list, in the item inside the list, but you could sort reverse order. So there's some we could do sort list reverse equals true. Why is this true? Yeah, reverse equals true. But what would this do? It will reverse the order. So you start from the back to the front. You get? Yeah, so when the other things you need to know, there is the extend, and talk about insert, I think we've talked about almost everything. And also then you could do the in to check if something is in something, like we did with string. Yeah, but at least you have the idea of how that can work. You could also use negative indexing for list. Yeah, so let's go to tuple. I think we're running behind schedule, so just do tuple. Tuples are also used to store multiple items. So with lists, you know that list, you can have duplicate items inside a list. So that you should know that you could have duplicate items inside a list. So tuples are used to store multiple items. Yeah, same with lists, but they are created using the curved brackets. So if I say, let me print my tuple, so just my tuple, if I put equals to this, so specifying this curved bracket already showed me that this is a tuple. So the tuple could be 3, 5. By the time I print type, if I want to check the type of what's in my tuple, it shows you that it's a tuple. Same with list, tuple can contain different items in it. So if I say, let me add something to this, different data types in it. So if I return this, if I print tuple, it's still my tuple. If I print out my tuple, it prints that out. So tuple can contain multiple items in the tuple. So one thing with tuple, you cannot change anything inside tuple. Once you've specified, like with list, you can extend, we can change, remove, insert, replace. But with tuple, once you specified it, you can't change anything in it. Yeah, so that's for tuple. You could create different types. They are ordered, and so with tuple, you could also index tuple. So you could also index tuple. You could also do indexing and slicing. I hope I'm not losing anybody at this point. So you could also do your indexing and slicing with your tuple, right? So I think that's tuple. So the main thing about tuple is you can't change things inside a tuple, and you specify your tuple using the curved bracket. That's for tuple. You could also check the length of my tuple. It shows you that you have 5 items in it. So that's what we call casting. Where, so for example, if I print out my list, here's my list now. This is my list. So I want to say, okay, let me say, I want to change this list to a tuple. So I can say, let me create a new variable. What should I call this now? I could call it X. Let's say X. I could say tuple my lists. By the time I print out X, what's the type of X now? It will return it as a tuple because I've changed it. So just calling tuple and put it in the square bracket, this could be lists. You could change this to a list. This could be a list. So if I print out type X, it's a list. So you call this casting. So you call whatever you want to use and you put it within the square bracket to change the type of that data structure. The next item would be sets. So we've talked about, for data structure, we've talked about lists, we've talked about tuple, we've talked about sets. So I could just specify my sets. So sets are also used to store collection of items, but you specify its set using the curly brackets. And same with other things. List can contain multiple data types in it. So you could say, let's have our cards inside. So we could have a string. You could have, let's say, dog. You could have floats, 2.4. You could have 5. You could have 7. Yeah, this is my set. So it's when the time I print out set, the type of set, it shows you that it's a set, right? One interesting thing about set is that you can't index sets. For example, if I do my sets, so they'll tell you they are unordered. So by the time I do this, it's going to return an error because set objects are not subscriptable. So you can't index or slice a set. Another interesting thing about set is with set, you can't have multiple items in a set. So I can say, let me define my set again and say cat. Okay. So why is it returning with a set? So I can't have, by the time I print it out, although I have 2 cats inside, you're going to return only 1 because with set, you can't have multiple, you can't have 2 the same items inside a set. Because for example, if I have this as a list, this first cat that has an index of 0, this last cat has an index of 1, 2, 3, 4, 5, has an index of 5. So you could contain it if it's a list. But with set, since set cannot be indexed, you can't use an index to locate the position. So it just calls only one of that item. I hope you get the difference. With set, you cannot index a set. You can't slice a set. You can't have same item, multiple items inside the set. It's one is one. Do you understand? Yeah. So with set, you can add items to a set. You could use the length function to check out my sets. Okay, so by the time I print out length, it shows me how many items I have in my set. I could also do the updates. So for example, I do, let's say, if you want to add two sets together, I could say my sets dot updates. So if I want to use this update function, I have to put it as a set inside. So by the time I print out my set, you see that Toyota has been added. Toyota has been added to the set. You get? So you can add that. Okay. You could do my set dot add. So with updates, you should understand what is the difference between them. With update, it has to be a set. So you have to put the curly bracket. But if I want to use the dot add method, I don't have to use a curly bracket. By the time I call my sets, you see that the Benz has been added, and the set just automatically sorts your item for you. So if you say I'm adding Benz, it's supposed to come at the last, but it's sorting it alphabetically. So it calls the number first. So that's what set does for you. It sorts your item for you naturally. So you could also do my set dot clear. So if I do this, everything inside my set has been cleared. So the dot clear, you can also use this dot clear for the list data structure. It clears everything inside here. So it just empties the list or the set for you. Yeah. So you could also go and look at other things you could do with sets. So then I'll just talk about dictionaries. Dictionaries are also used to store multiple items. But the difference with dictionary is that you specify your dictionary. With dictionary, you specify your index and the value. So I can say dictionary. Let me see dictionary. Let me still do my, I don't know why I like doing this. So you also use your curly bracket to specify your dictionary. But the difference is you specify what's the index and what's the value. I could say, okay, my dictionary, say name, then I use this column to specify the value. So everything before the column is your index, and everything after the column is your value. So I could say my name could be promise. Then I'll use a comma if I want to add another. So it's like telling this is equals to this, this is equals to this. I could say, okay, and another item in my dictionary could be country. I could use this and do Nigeria. So you are working with your both index and value. So your index or your value could be anything, could be any data type. Okay, I could just try a list as a data type. I can say hobbies. Let me do hobbies. So it shows that my hobbies, I could have it as a list. Pictures. I've said that pictures. I could say traveling, travels. I could say teach. Yeah. So by the time I run this, okay, see the problem. So there's a space before my dictionary. So that's why it's returning an error. So you should be able to debug when something doesn't work. You should be able to say why is this not working. My dictionary, by the time I print that, it shows you, okay, my name is this is this. So you can contain different data types within your dictionary, but with your dictionary, name itself in this dictionary is the index. By promise is the value. So your index could be, I could do index as 1, let's say 0. I could change my index to 0. I could change index to 1. Yeah. So by the time I print this and print this, shows 0 is 1, promise 1 is Nigeria, hobby. So it could be anything. Yeah. And I could also have a dictionary inside a dictionary. Yeah. So that's like your homework to go do. You could have a dictionary, you could have lists inside lists, could have dictionaries inside dictionaries.